Hello, welcome to STEM with Mr. Duda, and in this series I'm going to be talking about sensors and exactly how they work and the information that they are sending from the sensor to your device. And in this case I'll be showing you through an Arduino. So stick around. All right, hello. So today, this video is going to be about, I'm just doing the large microphone module, but the small microphone module works the same. I would imagine you've used a microphone before. Basically, what you've got is our voice, right? The vibration of our vocal cords, the air going past our vocal cords and the tightness of them uh, vibrates them, which vibrates the air, which vibrates typically a little diaphragm or something that receives the signal and turns it into a digital signal. Now, in our ear, the eardrum moves because the air is moving, and that is converted into, I'd imagine, an electric signal that's sent to our brain, and our brain figures out what those sounds mean. For this case, we've got a microphone right here. I don't know if that box will show up. Let me look. Okay, cool. So we have a microphone, and inside of that, I would imagine there's a little diaphragm that vibrates and creates an electrical signal. Um, for this sensor, the only thing that really threw me for a loop was this potentiometer. And I'll get to that in a second. There's a potentiometer here, which varies the amount of electricity going through. There is an LED here and an LED here. We have the normal, we have digital output 1. We have the voltage in. We have a ground, and we have an analog output. And so when we wire it up, it ends up looking something like, and let me full screen my webcam. It ends up looking something like this. So here and once again, I don't have the correct color wires, but we've got the microphone over here, and it's wired. I've got the wires running to analog. It's hard to do this. Analog 0. There's a digital pin over here, and then I have a positive and negative, which I wired to the rails here that run over to 5 volts and ground. Now, once you wire it up, and I'll get to the programming in a minute, but it's very important. If you look, if you can see the little blue box there, here's the blue box. There's a screw here. And what you need to do, and I'll see if I can show you on camera, what you need to do is turn the screw on the blue box, and I know I'm covering myself up. You're going to turn that screw counterclockwise. I'm going to turn it clockwise really quickly, and you'll see. You see how that LED just turned on? You need to turn this counterclockwise, and I'll be quiet, but turn it counterclockwise until the LED turns off. Right there. Now, you'll notice every time I talk, the LED, at least it was, the LED will come on. Now, mess around with the adjustment a little bit until it actually works, where you actually see it flashing a little bit. That's the ideal spot. It doesn't have to be perfect, but where you see it starting to flash when you're talking, that's going to be really, really good. Okay, I'm seeing it flash once in a while. All right, now let's go to the programming, and then we'll talk about this, okay? So let me go back here and then pull up my window. So the programming we've got right here, and I do recognize that's a little small, so let me see if I can get it larger for you. We can sort of scroll down on it. So I do recognize that's that's pretty small. If you need to see it even closer, go ahead and open it up in the link below in my description. But what we've got here, this describes that adjustment of the potentiometer. Then we have something called sensor analog pin at A0. That was what I ran from the, from the A0 to A0 on the pinout. Sensor digital pin, I ran digital, I think it said D1. Oh, D0, I ran that to number 7. You could run it to 0 as well. On the Arduino, it's just programmed to be on 7. Analog value, they're saying there's this variable, and we'll say it's equal to 0 right now. A digital value, we're not giving it a value. So perhaps on analog, analog variables, it's good to give it a number and not digital. I'm not sure about that. And then they're saying LED number 13, which it says defines the LED port. And this is the one built in to the Arduino. All right. So what ends up happening is we start the serial port, just like normal. We're saying the sensor digital pin. So number 7 is an input. It's going to take in something LED 13. So pin 13 is an output, so it's going to light up an LED. And then run this void loop, basically where it's saying analog value is the analog read, so read A0. And then digital value equals the digital read, read the digital read of what's coming from the digital pin. Okay, so basically it's just reading what is coming from A0 and D0 on your microphone little module. And then it's saying turn on the LED if the digital value is high and low. And this, I don't know. Maybe that's to make it flash, but I'm pretty happy with the LED that's built into it. None of this is very important. I mean, it is, but the good part about it, and you can sort of see how this works, the really important part right here is this. Okay, it's reading it and it's going to give us a value. It's going to print an analog value. Now I could print the digital value, but digital value is 0 or 1, so that's not very important. What I can do is I can click on my serial monitor, and let me switch this for you so you can see my serial monitor. Oh, hold on. There we go. Okay. So here's my serial monitor, and you will see, and I can change the size for you, not a problem. You'll see that their value is about 500. And if I put this up to closely to my face and I start making noises, it changes sometimes up to 600 and 700. If I tap it, you'll see some different values. But this, oops, I unplugged it accidentally. Good, it's still working. This is a weird way of looking at it. I'm going to show you an alternative, okay? So instead of choosing the serial monitor like we normally do, instead of choosing that, and I know you're not going to be able to see my menu, but if you click on Tools and then say Serial Plotter is going to be very, much more useful. So let me switch over to Serial Plotter for you. And you'll notice on Serial Plotter, and I'll move my camera, you'll notice on Serial Plotter, it's going to start showing us some values. Testing, 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 testing. So I'm realizing you can't see where, let me move this over, okay? I will transition it. Test, test, test. So now you see that when I'm talking, it actually gives us that normal sort of feedback. All it's doing is taking those values from our serial monitor, the information it's getting directly from, I believe, just the analog pin, and graphing it. And that's sort of where we get our waveforms. So that was the sound sensor example. If you're trying to get it to work, that potentiometer is very important. If you don't have a potentiometer built into it, you're probably going to want to wire a potentiometer into it. I believe this is a 10,000 kilo ohm. I'm not sure. Yeah, I would just look at the specifications for your sensor. But there you go, and have a wonderful day.